All right, so let's get started on another lesson here. So we are now going to talk about sketching graphs of functions, right? So we're going to use everything that we've gone over so far in this chapter, right? So we talked about basic functions and how they work, and then we talked about what makes a function linear versus nonlinear, and then we talked about what makes it symmetrical or not symmetrical. You have line and point symmetry, and then we talk about end behavior, what's going on with this thing, and then we talk about relative maximums, minimums, or we call it maxima and minima, extrema of functions. So now we are going to we're going to learn a few more terms, and then we're going to take this all and we're going to put it all together, and you're going to get descriptions of functions and you're going to sketch them. And that's the whole premise and idea behind this lesson. Okay, it's how to take everything you've learned. We're going to add a few new elements to it now, and then we'll take it all together. We'll synthesize it, and we'll build functions basically from words. Okay, so we're going to do linear and nonlinear functions as shown here, sketching linear and nonlinear functions. But before we do that, we have to quick go over some key vocabulary and concepts so that we are absolutely sure on what we're talking about here. Okay, so x and y intercepts we should be familiar with already, right? And x-intercepts where the graph crosses the x-axis. Remember, your x-axis is right here, and then this is your y-axis, right? And I've got a graph here. So when we talk about our x-intercepts, right, and we'll say that our x-intercepts are red, right? And so we talk about our x-intercepts, that's going to be, in this graph, going to be right there, there, and there. And so a lot of times when they describe these functions, they'll be like, it has an x-intercept, or it has two x-intercepts at blah, blah, and blah, blah. So you know that's where it's crossing, and it's just a matter of whether it's, going left or right going up and down, or if it's going, from down, if it's heading downwards or heading upwards or whatever it's doing. But you at least know where it's crossing. Okay, now our y-intercepts, we use green for this, right, is where does it cross our y-axis, okay? And generally speaking, there's usually only going to be one of those per graph, all right? And sometimes you won't even have one, but the most you will ever have is one of those. You can't have more than one where it's crossing the y-axis, because then it's not a function. Because remember, functions are... what makes a function is the fact that it passes that vertical line test, whereas if you're going from left to right, each x value can only be assigned one y value, right? You can have y values that repeat, but they can't repeat on the same x value, right? That it has to be varied up, okay? Now, something new here, positive and negative, all right? So what you think about for this, right, is I'm going to take this right here, and I'm going to draw this kind of through this is our x-axis, right? And if you think of this kind of like as the ground, positive, right, is going to be where this thing is above your x-axis. And so that's, oops, this doesn't look very good now, does it? So that's where you have something that is a positive function, right? So on this function right here, okay, and now I'm gonna erase a bunch of this garbage here, right? Okay, so we can see it, okay? We know it's positive if it's above, we know if it's below, it's negative, okay? So on this function, between -2 and 2, it's positive. And they would say it like this, x greater than, equal to -2, or less than or equal to 2, they would say the function is positive, right? So, and it is, right? And then between 2 and 5, they would say it's negative because it's below the x-axis at that point, and that would be at 2x and then going up to, you know, positive infinity, or they would say it as x greater than or equal to 2, right? So you could write it those two ways. And then it's also negative as x is less than or equal to negative 2. So after this one, it's negative, right? So it's negative in two spots, you know, and it's positive in two different spots, right? And they're going to be different, right? But that's how you can tell if something's negative or positive. Now, don't get that confused with increasing or decreasing. We're going to talk about that in a second. Positive and negative is only has to do, right? Only has to do with its relation to the x-axis, right? So if you think of the x-axis as kind of like the ground, right? If it's below ground, it's negative. If it's above ground, it's positive, okay? So whatever you got to do to remember that, you go do that. But it's just, you know, positive is above the x-axis, negative is below the x-axis, all right? And when they tell you that it's positive or negative at that, when they're giving you those threshold points, that's where it's crossing. Those are also always going to be your x-intercepts, right? So when they tell you those are also your x-intercepts, right? And I'll write that down. Also, x-intercepts. Now you'll notice that this page and the next page are not in the notes that you have for this. So if you have to like take screenshots of the video or whatever as we're going through this, you know, go right ahead and do that. But just remember this positive and negative. Right, now, this last thing, before we're going to stop the video after this, and then the next videos will deal with actually sketching these things. So the other three terms are increasing, decreasing, and end behavior. So increasing, right, as the x value increases, the value of the function increases. That basically means, right, that is a fancy way of saying it has a positive slope, right? It has a positive slope. So if left to right, it goes up. And as the x value increases, the value of the function decreases. That is describing decreasing. That is also describing negative slope. And we know all about those, right? Negative slope. So if m is greater than, you know, 0, right? If your slope is greater than 0, then it's positive, right? And negative is when m, which is your slope, is less than 0, right? So in this example right here, right, we can see that this thing is increasing, right, until it gets here. And then from here to about here, it's decreasing, all right? And then from this part, and I'll mark it, from this part on, right, going on up, it's increasing. Okay, so it's always left to right. It's always left to right. So it's the way you read, right? And that's how we always look at slope. That's how you look at increasing and decreasing, right? So if you can just think of it in terms of slope, I don't think it's too complicated. And then end behavior, there's a whole lesson on end behavior, right? And describing how the values of the function behave as x goes to positive infinity. They don't write the positive sign here, but that's what that means. And as x goes to negative infinity. So for this one, your end behavior would be as x goes to positive infinity, comma, f of x, the function value, also goes to positive infinity. And then your other one, I'm writing it below this, right, because I'm a disaster here, as x goes to negative infinity, right? So now we're talking about as this thing goes this way to the left, your y, f of x, also goes to negative infinity, all right? And you can have that when you have a cubic function, right? That doesn't happen on quadratic functions. That happens on cubic functions and on linear functions, okay? So that's end behavior, just kind of a reminder of what it looks like, all right, and the kind of notation that we use. So in the next videos that we have, we are going to look at sketching these just based upon words, and they'll give us a blank graph, and we'll get started. So I'll see you in the next video.